Hello everyone and welcome back to my channel. In this video, we're diving into Thevenin's theorem, a powerful technique that simplifies complex circuits into a simple equivalent circuit with just a voltage source and a resistor. So stick around as we break it down step by step. But before we start, if you're new to my channel, please subscribe and hit the like and notification bell so you won't miss any of my upcoming videos. Let's begin. In this circuit, the components are connected as follows. The 15-volt voltage source is connected to terminals A and B, with A being the positive terminal. The 6 kilo ohm resistor is connected between A and C in series with the voltage source. The 5 milliampere current source is connected between C and D, supplying current upward from D to C. The 2 kilo ohm resistor is connected in parallel with the current source between E and F. The variable load resistor is connected between G and H across the 2 kilo ohm resistor. Our goal is to find the current through the load resistor if the value of the resistor is A, 2 kilo ohms and B, 5 kilo ohms using Thevenin's theorem. So in order to solve this, first, we remove the load resistor and focus on finding the Thevenin equivalent circuit across the open terminals G and H. To find the Thevenin resistance, we deactivate all independent sources. The 15 volts voltage source is replaced by a short circuit, and the 5 milliampere current source is replaced by an open circuit. Now, we find the equivalent resistance across terminals G and H. To find the resistance as seen from the open terminals G and H, R1 is in parallel with R2. So therefore, equivalent resistance is equal to 1 over 6 kilo ohms plus 1 over 2 kilo ohms, which is equal to 1.5 kilo ohms. So this is the equivalent resistance as seen from the terminals G and H. So therefore, Thevenin resistance RTH is equal to 1.5 kilo ohms. Next step is to find the Thevenin voltage across the open terminals G and H. To find the Thevenin voltage, we use superposition theorem. The Thevenin voltage is equal to the sum of the individual voltages due to the individual sources. We first solve for the voltage due to the 15 volt voltage source, and we call it V1. Okay. So, the voltage across the open terminals is equal to the voltage across R2, which can be calculated using voltage divider theorem. The voltage across R2 is equal to VR2 is equal to 2 kilo ohms divided by 2 kilo ohms plus 6 kilo ohms multiplied by 15 volts. This is by using the voltage divider theorem. This will be equal to 3.75 volts VR2. This is also the same as the V1 due to the 15 volt voltage source. Okay, next is we solve for the voltage across the open terminals due to the 5 milliampere current source. So, in order to do that, we replace the voltage source with a short circuit. As you can see in the equivalent circuit, resistance R1 is parallel to R2. So let's get the equivalent resistance first. Equivalent resistance is equal to 1 over 6 kilo ohms plus 1 over 2 kilo ohms. Equivalent resistance is equal to 1.5 kilo ohms. The voltage across the open terminals G and H is equal to the voltage across the parallel combination of R1 and 2. So let's call it V2. V2 is equal to 5 milliamperes times 1.5 kilo ohms, which is also equal to 7.5 volts. So Thevenin voltage therefore is equal to the sum of the two voltages, V1 plus V2, is equal to 3.75 volts plus 7.5 volts. So Thevenin voltage is equal to 11.25 volts. So now that we have the Thevenin voltage and we also have the Thevenin resistance of 1.5 kilo ohms, we can now redraw the equivalent circuit. So this is the Thevenin voltage ETH, which is 11.25 volts, and this is the RTH, which is equal to 1.5 kilo ohms. So now, if RL is equal to 2 kilo ohms, the current through RL is equal to the current of the total circuit. So IL is equal to 11.25 divided by 1.5 kilo ohms plus 2 kilo ohms. So therefore IL at 2 kilo ohms is equal to 3.21 milliamperes. And then IL, if the load resistance is at 5 kilo ohms, is equal to 11.25 volts divided by 1.5 kilo ohms plus 5 kilo ohms. This will be equal to 1.73 milliamperes, 5 kilo ohms. And there you have it. We successfully solved the circuit using Thevenin's theorem, turning a complex circuit into a simple one. This method is super useful when analyzing circuits with varying loads. If you found this useful, give this video a thumbs up and subscribe for more electrical engineering content. See you in the next one. Thank you and God bless.